definition, we're going to take a look at sets and using sets to find probabilities. That's thinking, what's a set? A set, all it is a simple collection of things. So numbers or objects that have a well-defined criteria. Okay? The things that are contained in a set are called elements. And a subset, we'll go look more in depth with a subset. All that is just a set contained within another one. So you're using a set to create a new one. You're stealing things from another set to create a new set. That is a subset. So we take a look at example 1. It says let set A be all the numbers greater, not a cheese grater, greater than 0 and less than 10. Write out all the elements of set A. Okay? Well, they said our set name was A, so I'm going to write A. And then I'm going to write all the numbers that fit into that criteria, which is all the numbers between 0 and 10. So are 0 and 10 going to be included in our set? Is all the numbers in between them? No. If it said all the numbers from 0 to 10, yes, we would include them. But it's all the numbers in between. So what are all the numbers in between 0 and 10? 1 through 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then technically, you put those squiggle brackets around those numbers. We're not picky on the squiggle brackets. If you can't draw squiggle brackets, you don't feel like drawing the squiggle brackets.
Can I split parentheses? Or does it have to?
No, squiggle brackets or no squiggle brackets. Don't put parentheses.
Don't put anything there if you want to draw this.
And there we go. There's a set. Has well-defined criteria. We wrote everything that fits that criteria in our set.
That's a squiggle. That's my squiggle bracket.
And if you're like, I'm not going to draw squiggle brackets, that's okay. We're not picky. So if you take a look at example 2, it says, again, a subset is a set contained within another set. So what we're going to do is take the set we made in example 1, which is 1, 2, 3, 4, 5, 6, 7, 8, 9, and create subsets from those. Okay? And we're going to come up with our own criteria. We're going to come up with our own definition. So we're dealing with numbers 1 through 9. What's one definition of a set? Think what type of numbers are there? Odds. Okay? We can make set B all the odd numbers from set. That is set B's criteria, definition. All the odd numbers. Well, then what you have to do to make set B is write down all the odd numbers from set A. What are all the odd numbers from set A? 1, 3, 5, 7, 9. Well, let's make another subset. What could be the definition of another subset? All the evens. Well, what are all the even numbers that are in set A? 2, 4, 6, 8. So those are all the elements that are going into set C. And those are subsets. Okay? You could have done anything for set B and C. You could have said all the numbers greater than 5. You could have said multiples of 3, multiples of 2. You could have said all the prime numbers. Okay? You'll have a question like this in your practice, and you can get creative with it if you want to. I would say, like, I would word it if you want to do that, all the numbers less than 5. It's more like practical way to write it. Because they're not necessarily like written in order. Questions? Over there. Okay. So before we dive into using this to help us find probabilities, we have to talk about one important vocab word, which is called a complement. And it's not the typical compliment you think when you hear that word. Like, hey, I like your shirt today.
There you go.
Okay? Complements and probability, all that is all the outcomes that do not fall into an event. It's all the ones we don't want. Okay? The opposite, the leftovers, things like that. Okay? When you see the word complement. So, for some examples are when an event is landing on heads, the complement is landing on tails. If the event is landing on heads, the complement of that is not landing on heads, which is landing on tails. Oh. So when an event is rolling an even number, the complement of that is not rolling an even number, which is rolling an odd number. That's the complement. It's everything that doesn't fit into a given event. I like to think it's opposite, leftovers, things like that. So we take a look at example 3. It says, consider an experiment of tossing a fair coin and then rolling a 6-sided dice. Okay? Write the sample space. So we write our sample space. I like to think, well, what am I doing first? And because more than just one thing is going on, we're going to have to write it as ordered. So if you flip a coin and then roll a die, or vice versa, or if you flip a coin twice, or if you roll a die twice, or spin a spinner twice, you're going to have ordered pairs. Okay? So just keep that in mind. Sometimes it'd be like, we see it a lot, is you'll roll a 6-sided die twice, and students tend to write 1, 2, 3, 4, 5, 6. Okay? So there's more than one thing going on. You're going to have ordered pairs as your sample space. Okay? Well, we're flipping a coin first. So we flip that coin. What's one possible outcome? Landing on tails. Good. And then we roll the die, and as Kayla said, you're going to land on a 1. And we write our sample space. We like to go in order so we don't forget anything. So we're going to continue this pattern with tails first. So we get tails in a 1, then we can get a tails in a 2. We can get a tails and then a 3. A tails and then a 4. Tails and then a 5. A tails and then a 6. Are we going to get a tails and a 7? No. Oh. So it's 6-sided die and then 6 numbers. Sometimes, I'm guilty of this myself, I get on a roll, and I go tail 7, tails 8, tails, and I go crap. How am I supposed to go to 6? So just pay attention to that. Okay? So that's everything with getting a tails first. Okay? What's another outcome getting first besides tails? Heads. Okay? You can get a heads and then a 1. You can get a heads and then a 2. A heads and then a 3. Heads and a 4. Heads and then a 5. Heads and then a 6. Those are all the possible outcomes that could happen. We didn't actually run the experiments, we don't really know what happens. Those are all the possible outcomes. B says write a set that represents the event of getting a tail and an even number. Call this set A. So we're going to say A equals, put a squiggle bracket, don't put a squiggle bracket, it's fine. Then you're going to write everything from that sample space that fits that criteria. Okay? So what can we write down for getting a tail and an even number? What's going to go in our set? T what? Good. Those 3, T2, T4, and T6 all fit in that set. The only 3 from that fit that criteria. The only ones that are going to go in set A. Set B is the complement of set A. Write out all the elements of set B. So again, complement is all the things that don't fit in an event. So if the event is getting a tails and an even number, the complement of that is not getting a tails and an even number.
So it's having
Yes, it's all the heads and all the ones that are tails and on. So all the ones that we did not write in this first set, we are then writing in the second set. All the leftovers. All the ones that don't fit in A are its complement. It's going to go in B. So tails and odd ones go in there. So T1, T3, and T5. They didn't fit into that event. They didn't fit into set A. And then all the ones that have heads. So heads 1, heads 2, heads 3, heads 4, heads 5, and 6. Those are the squiggles. Now in D, we're going to find the probabilities of these two sets happening. So we're going to find the probability of A, just like we did yesterday. Draw your fraction. What goes in the bottom of your fraction is the total outcomes. How many total possible outcomes did we have? How many parentheses did we have in our sample space? 12. Okay, of those 12, how many fit into set A? 3. So 3 out of the 12. And then reduce fractions if you can. What does 3 out of 12 reduce down to? 1/4. Which is what as a decimal? 0.25. Which is what as a percent? 25%. Okay. Well, now let's find the probability of B happening. Not getting a tail and an even number. The probability of B. Well, same sample space, so 12 is still going to be in the bottom. Of those 12, how many fit into set B? 9. 9 out of the 12. What does 9 over 12 simplify down to? 3/4. So what's 3/4 as a decimal? 0.75, which is 75%. What are you noticing if we were to add these probabilities together? They equal 100%. If you add the fractions, they equal what? 4/4, which is 1. So when you add the percents, you get 100%. When you add the fractions, you get 1. Okay? That should happen every single time. A probability and its complement are always going to add to 1, or 100%. Because A was fit into our event. B was all the leftovers. So at the end of the day, when you count everything that's in A and everything that's in B, you get the total sample space, which is 100%. It's everything. So that's why they're always going to add to 1. So if we know a probability and its complement add to 1, what could have been a shortcut? If we knew the probability of A was 1/4, what can we do with 1/4 and 1? Subtract them. You could have just done 1 minus 1/4, and that would have given you the probability of B happening. Because if there's a 1 out of 4 chance A is going to happen, well, that means the other 3 out of 4 are not going to happen. Okay? Same thing when you have percents. If you knew, oh, there's a 25% chance of A happening, when you have percents, just subtract them from 100. So 100 minus 25 means there's a 75% chance that A is not going to happen. It's complement. Super important thing to know. Questions over that?
Alrighty, flip it over. Let's do some of that practice. More examples here. Second flip here. Consider rolling a 6-sided die and record the result. Let's have set A be the event of rolling a number that's greater than 4, and let's let set B be the complement of set A. All right, so we're starting with set A. We want to know if on a die, you guys got to use some mental imagery here. On a die, how many numbers are greater than 4? 2. What numbers are they? 5 and 6. Okay, so my set A, just talking about this, is going to be 5 and 6. That is all that's going to be in there. If I want to get greater than a 5 or greater than a 4, it's going to be one of these two numbers. We're going to have B be its complement. Okay, well, what numbers are less than 4?
1, 2, 3.
And yes, so 4 is also in there because 4 is not greater than itself. So we know that we're going to have 1, 2, 3, 4.
Wouldn't it mean 4 is not less than?
It says greater than 4. So 4 is not greater than 4, right? It is 4. So, and also too, when we're talking about complements, just like we talked about a second ago, we want it always to add up to what? When we're talking about itself, an event and complement always add up to 1 or 100%, whatever it is. If there's a 6-sided die, we better have 6 numbers. Okay. Well, now it says let's find the probability A, and let's find the probability B. We can do that. So we're going to find the probability of A. Well, how many total events could happen? On a die, how many different outcomes could there be? On a die, how many different? 6. There's 6 outcomes that could happen, right? So we have 6. Of the one that we chose, we're talking about numbers that are greater than 4. You said there are how many? 2. So what do I need to do with this? What do I need to do? It would reduce it down, and we get a 1/3. But we also want to know what that is as a decimal, because sometimes you deal with fractions, sometimes you deal with decimals, sometimes you deal with percents. 0.33, exactly right. So as a decimal, it would be 0.33. What about as a percent? Good tag team effort, everybody. I don't know who said it, ventriloquist everywhere. Maybe back there, somebody said it. 33%. And again, remember, all you take the decimal and you move it over 2 to the right. That's what I do. So we have a 33%. What do you think the probability of B is going to be? Maybe. I don't want to ruin the surprise for everybody. We'll find out. 60 something? Yeah, we'll see. So let's do the probability of B. Well, how many outcomes can happen in B? Oh no, set B. 4. 4, we still have total of 6. 4 happened there. We reduce it down. Mason already rooted for us and said it was 2/3. 2/3 as a decimal is, get around here, it'll help out. 0.67, yes. 0.67. And then we know that 0.67, move that decimal over twice, is going to be 67%. Good. And you know that you did it correctly because just like we talked about it, it should add to 100%. It should be 1. It should be a whole 1 as well. So they all work out there what it is. Easy way to check. If we could do this a lot quicker, we know it's complement, we can easily, or excuse me, we know the event, we can easily figure out its complement. Questions on that?
No question.
Okay, then we're going on to numero 5. So this is nice. I do this in weather all the time. I yell at the meteorologists at the TV because they're always wrong. But it says the probability of rain tomorrow is 40%. What is the probability that it's not raining? 60%. Yeah. Well, we know that we have 100% is what it is. If we want to figure out its complement, can't you just do 100 minus 40? Because it should add up to be 100. 100 minus 40, we know is going to be 60. So it should be 60% chance that it's not raining. It's a very optimistic math problem right here. It's going to rain 40%, but 60% is not going to rain. I'll take those odds. Because they're wrong half the time. It'd be nice, but you won't get it tomorrow, so. Number 6. Hey, Josh. There's your name up there. So number 6. This is a multiple choice one. Don't let it fool you here. Fooled me earlier. Josh has a bag containing pieces of candy. The bag contains 6 red circle pieces, 10 red square pieces, 10 blue triangular pieces, and 10 blue star pieces. He draws a red piece of candy from the bag. What is the complement of this event?
Hey, Josh, yes.
So what is a complement? Draws a blue piece, draws a square piece, draws a circular piece, draws a star-shaped piece.
Don't let us fool you guys.
Nope, you just pick one. So which one of these is the complement to him pulling a red piece of candy from the bag? A. Because we're talking about the color of the candy, right? Which one of these represents the color of the candy? It is the opposite of the other color. Well, the only one that's telling about color is A. The other ones are talking about shapes. We had nothing regarding shapes, so not that.
What did you do?
I just did that, just so you guys were paying attention. It is he draws a blue piece. Try that again here. Draws a blue piece. Sorry, people watching at home. We are centering the board at this moment. Try that again. Don't do that marking. Let's just do A. There we go. Draws a blue piece as a complement of drawing a red piece. Good? Oh my gosh. Oh my gosh. Can't get the page. There we go. Now we're good. All right. Number 7. This one's tricky, actually. I gotta pay attention. Got me. An online retailer conducts a random survey of its customers. The survey shows 80% of the customers receive their purchases within 4 days, and 95% of those customers are satisfied with the quality of their purchases. What is the percent of customers that receive their purchases within 4 days that are not satisfied with their purchases? Eyeball glance, I know what you're going to say. I did the same thing myself, just reading through this, skimming it. You see 95%. You say, what's the complement of 95%? You're saying it's going to be 5%, right? And I would agree if that was the case. But the case says we want to know that received their purchase within 4 days. What percentage received their package within 4 days? Only 80%. Only 80% of theirs received it. Yeah, so right there. 80%. Okay? So 80% received it. So we got to figure out what is 5. We know it's 5%, right? What is 5% of 80? Because only 80 received it. How do we figure that out? Well, you need to know this skill. Use it at the mall, shopping, trying to find a discount on an outfit or whatever you guys are buying these days. Well, we need to turn it into decimals. How do I turn 80% into a decimal? Move the decimal over, so 0.80. Yes, essentially is what it is. So I know that when I do it, it's going to be It's going to be 0.8. Okay, I apologize, computer people at home.
It's like too warm in here and like there's more air.
Just letting you know, computer people, I am writing in the middle of the board and it is dropping to the bottom, so you see what's following at home. All right, so we have it 0.80, or just 0.8, doesn't matter. Just in that placeholder. And we're going to multiply that by 5%. But what is 5% as a decimal? 0.05. So I'm going to multiply that by 0.05. And that is going to tell me what is my percentage off there. Kayla, what we got? 4%. 0.4 is what you should, or 0.04 is what you should have got. And converting that in, you will get 4%. So only 4% of the people who received their package within 4 days were not happy. Had we had 100% of that rating, we could figure out the rest. Very tempting to say B, though. I agree.
That means 76% of the 80% were satisfied. If you do 4% plus 76%, you get 80%.
That would be, yep. Questions on that? Okay, I'm just going to, there we go.
But, of the time,